Hello, everybody, and we are moving on to rectangles. Okay, so after today, you will be able to use properties of rectangles to find missing angles and side lengths. Okay, here is just a little like family tree, right? So basically, this chapter is all about quadrilaterals, right? And that's just a four-sided polygon. And from that, you're either going to have shapes that are non-parallelograms or parallelograms. So we spent the last few lessons talking about parallelograms. And remember, that's a four-sided figure with opposite sides that are parallel. And now today, we're going to talk about a specific kind of parallelogram, a rectangle. Okay? So since, let's see here real quick. Okay, that's fine. Since a rectangle is a parallelogram, all of those properties of a parallelogram are true of a rectangle. But then what differentiates a rectangle from a parallelogram are these two properties right here. So all four angles are right angles. So all those corner angles are right angles, which I think we already knew, but now like we formally know, right? And then the other thing that makes a rectangle compared to just a regular parallelogram is that the diagonals are congruent. So AC is congruent to BD. They are the exact same length. So again, the angles in the corner are right and your diagonals are congruent. Let's see if we can find some side lengths now. Okay, it says given the measures, find, dun, dun, dun. Okay, here we go. So QR, well, QR is opposite PS, and since PS is 10, so is QR. SR is opposite PQ, and we know that opposite sides are congruent, so SR is 24 as well. Now SQ is a diagonal, right? And we learned that these corner angles are all right angles. So folks, if you look here, I want to highlight this triangle out. It's a big right triangle, right? So I can use the Pythagorean theorem to figure out how long SQ is. And that would be our hypotenuse because it's across from that right angle. So to find SQ, we could do 10 squared plus 24 squared equals x squared, which would be our diagonal length, what we're looking for. So we're going to get 100 plus 576 equals x squared. Add those together to get 676. Then our last step, of course, is to take the square root. And we get a nice whole number of 26. So now we found that our diagonal length is 26. PR is our other diagonal. And remember, our diagonals in a rectangle are congruent, so that's also 26. And then our last length we are looking for is QT. So that's half your diagonal. So 26 divided by 2 is 13. And if you're forgetting, why did I know it's half? Well, remember, in a parallelogram, your diagonals bisect each other, which means they cut each other in half. So this half is equal to that half. Pretty easy, right? Not too bad, I hope. Okay, next, let's look at the angles. Okay, so I sometimes just wish they'd give us numbers, right? Like I just want to trace all these out, but that's okay. Here we go. We are looking for angle MJK. MJK. MJK is this corner angle, so really just angled that big angle J, and we know that all of our corner angles are 90. Now we're looking, let's put 90 there so we know. Okay. Now the measure of angle MJL is this other piece of 90. So if this part's 27, what's left over are 90? Well, 90 minus 27 should be 63. So this guy right there, 63. Okay, now angle JLK. Angle JLK. This guy right here. Well, lucky for us, folks, we know we have a bunch of alternate interior angles. So this angle here is alternate interior to 63. So that's not too bad. That's just plain old 63. Measure of angle KML. KML. This guy right here. So, folks, there's a lot of symmetry now in the rest of the chapter. So, like, you have a lot of things that are equal. Since our diagonals are congruent and we cut them in half, we have a bunch of isosceles triangles in here, meaning if this angle right here is 63, this angle right here is 63 because our base angles are equal because they're across from congruent sides. So same thing with here. If this one's 27, this angle's 27. This angle 63, the one across from it 63. Do you see the pattern? So this angle is 27, as would be this one. So the measure of angle KML is 27. And lastly, the measure of angle MNL. MNL is this guy right here. So 180 minus 27 minus 27 should give us 126. So it's kind of cool as we only knew one angle measure in this whole picture and we were able to figure out every single other angle by just working around the picture. Again, don't forget that you have just a bunch of patterns. That's all it is. Look for the pattern. Okay, let's piece those two different examples together. So we have a bunch of angles and sides we're looking for. So if we label what they give us, DB is our diagonal of 42. So if the whole thing is 42, then I would know that this chunk here is 21, as would this chunk be there. AD is 26. And the measure of angle DAE. DAE is 52. Okay, let's see what they want. AC is our other diagonal. So if this diagonal is 42, so is AC. EB we wrote as half our diagonal, so half of 42 we said was 21. These aren't degrees. BC is the same as AD, so 26. And then to find our other side AB, we do have to do the Pythagorean theorem again, folks. So we're going to have, let's call it X. We'll have 26 squared plus X squared equals 42 squared. 26 squared, 676 plus X squared equals 1764 minus 676, oops, X squared equals 1088. And again, our last step is to take that square root. And we should get approximately 32.98. So we'll just approximate to 33. That's close enough. So 33. Now let's check out our angles. Okay, let's just fill in our picture and then we'll see what we get, okay? Because I want to practice you guys seeing that pattern. So think, if this is 52, alternate interior tells me that this guy here is 52. And remember, we have isosceles triangle, so if this base angle is 52, as would this one be. And same with this guy over here is 52. Because again, there's a lot of symmetry and we have isosceles triangles in there. Now to find their counterparts of that corner angle, we subtract from 90. So 90 minus 52 is 38. So now all those other parts of those corner angles are 38. Sorry, kids. I don't know why this always pops up. Okay. And then lastly, to find like these middle angles, pick a triangle and subtract from 180. So if I wanted to do this one right here, 180 minus 104 would give us 76. 76, because they're vertical. And then we would know 180 minus 76 would give us that 104. And there you have it. We just found all of our angles based off of one angle measure again. Again, we have a lot of symmetry and a lot of other things that we have from prior knowledge to help us solve that. So now if we fill in these blanks over here, angle ADC is just that corner angle, so that'd be 90. ABD is our 38. BCA, 52. And DEC is that middle one that we found to be 104. If you're still lost, don't worry. We will do desk problems in class for you to work these out in front of me so I can help you, okay? So no worries there. And then, of course, let's do a little algebra together. We are looking for the measure of angle XZW. XZ, so this guy right here is our end goal. So in order to find that, we have to figure out what X is first, right? And we know that we have alternate interior angles here. So this angle here, this guy, is the same as this one here. And these two angles in the corner have to add to 90. So we can take this expression plus this one and set them equal to 90. Add your like terms. Bring over your 12. Lastly, divide out. You should get x equals 13. And now plug in. So remember, alternate interior is telling us that this is the same as that guy right there. So if I plug in 13, 5 times 13 minus 8, 65 minus 8, 57. 57 degrees. Then our final example for today, solve for the variable. So we're looking for x. A few different ways to go about it, but just initially how my brain sees it. I'm going to figure out what this angle next to 134 is. So if I take 180 and subtract 134, I get 46. And now, don't forget, this is an isosceles triangle in here, right? So this angle here is the same as this angle here. So I can write 5x plus 7. And I know together all three of these things have to add to 180. So you can write nice long equation. Again, there are shortcuts to this, but I'm just going to be thorough in case you don't see them right away. So again, all three of these angles have to add to 180. Add your like terms. 14 plus 60. Okay. Subtract over your 60. And lastly, divide out. You should get 12. Super. We're done. Good work. Thanks for listening. If you're still here up to this point, have a super day, and I will see you in class. Adios, you guys.